Thank you, Robert. Firstly, thanks for that opportunity and thanks for your invitation about that. Today, I will present our low carbon, high performance cement and concrete strategy on GBFS. I'm joining from OYAK Cement Group from Turkey, and I am Performance and Process Director of Group. I want to start with quick info about our OYAK Cement at a glance. We are the leader in Turkish cement market as producing cement and also the market leader. And also we are again the leading company in ready-mix concrete operations. We have 12.4 million tons of clinker production capacity and 22.5 million tons of grinding capacity, and also more than 9 million meter cubes of ready-mix operations. We are available in nearly every region in Turkey with our cement plants and grinding units, and also available in all the regions, all territories with our ready-mix operations. About the GBFS issue, it's just our group has 2 iron and steel plants in Turkey, and we are just with that synergy. One of our most important cementitious material is granulated blast furnace slag. Today I will just explain that part also to you. Just when you look on the GBFS in Turkey, there are nearly 3 million tons per year production is available in Turkey, and that's nearly 75% of that GBFS output comes from OYAK companies, OYAK Iron and Steel Group. When we look on GBFS, just I want to quickly just about some technical info. Does everyone knows that? But it's also everyone knows that. But I also want to explain a little bit about that. We could gain measurable improvements with GBFS usage, better workability, easier finishability, lower hydration heat, higher compressive strength, especially after 28 days, later strength specifically. Lower permeability, strong resistance to chemical attacks, more plastic consistency, improved hardened properties, lighter color compared with OPC. It's also important in aesthetical issues, and also just the reflection of light. It's also critical, and also eliminated fluctuations in air content due to its structure of granulated blast furnace slag. When we just look on the chemical effects at hydration stage, the biggest advantage of GBFS is its compatibility with other pozzolanic materials. And in cement, it reacts inside the cement in hydration process. It reacts with free calcium hydroxide and performs calcium silica hydrogels. By the help of that one, high CSH gels, the lower permeability can be achieved in concrete. And resistance on chlorine and sulfate attacks with lower permeability, proportionally decreasing aluminate phase, aluminate content in GBFS, and minimizing sulfate reactions by the help of low alumina contents. Higher strength growth over the lifetime, as I said, especially after 90 days, still the strength development goes with GBFS, and works properly with chemical admixtures, and especially regularly used ones in concrete operations. Just I want to give again some quick details about that. It's in the concrete mix and its effects, what we are looking for according to our experiences also. Just the basicity of the product is critical, especially for the early age reactivity. And titanium oxide and aluminum contents are important figures in chemical reactivity part. Glass content is critical. It's related about the granulating stage, and its solubility is also important. And while adding that GBFS in the cement and also in concrete stage, it's curing environment because its hydration, heat evolution, and water evaporation trend is critical. One of the advantage of GBFS, but also at the other side, it should be controlled well. And chemical properties of cement component. it's also critical. While we are producing GBFS blended cements, we are checking their adaptation and compatibility. Also in the ready mix stage, we are producing and making our designs according to that specific receipt requirements. And GBFS fineness and particle size distribution is also critical. We are adjusting, and one of the critical part is this. When we look our high performance products with GBFS, we have some brand names in here. I want to show some of them in here. Cementum, it's one of the highest early and late strength product with slag usage, and it's very good resistance on environmental effects and low carbon footprints when compared with competitive products like SEM 142.5 and SEM 152.5. and higher workability in concrete. Our leading product in Marmara region, we are competing with SEM 142.5 and 52.5 of cements with that our specific product, and we use its advantage on the concrete stage, and because of that, it's very known and popular product in that region. Some projects, as you could see, that it's in stadium project in Istanbul. We used that product. We gave that product for that project. The other one is the Power Sem. It's Power Sem. It includes much higher slag in it when compared with Cementum. It's just again higher strengths and late strengths, and also one of the lowest carbon footprint cement in Turkey with that strength performance. Again, it has a high workability concrete. Just some metro lines we used so that's just a specific project as a giving that one. It's these projects. The critical part, it's strong chemical attack resistance with that product again. One other is Starsem. It's just again, it's an important product for us. Low hydration release and moderate to high workability on concrete. Some bridges and some as you see, it's just some health campus construction. We gave that product also used. The other specific products with the increasing amount of slag, it's Durasem series. Durasem, it's very strong chemical attack resistance. We could reach up to more than 40% slag with the class of 42.5 class of cement type. Optimum and early strength, effective hydration control, again higher workability, but one of the most important part is also just only 450 kg per CO2 per ton cement carbon footprint. It's an ecologically it's a green cement, one of that one with that performance. We just serving with that cement to do some port activities specifically. The other, it's the 32.5 class cement. It's the highest GBFS containing cement. It's a specific product, Durasem Plus. It's extreme chemical attack resistance, extreme hydration heat control performance, strong compatibility with specific admixtures for challenging requirements. And it's also one of the lowest carbon footprint cement with that properties in the market in this region. And it's used in many specific projects like Avrasya Tunnel project, and Osman Gazi Bridge, and Tripoli Harbor, and there is a mosque in Istanbul again. It's used, but the main advantage is that, as I said, it's highest chemical attack resistant to sulfate, chlorine, and other effects. And we are producing GGBFS also for grinding that one, to both use in cement, and also we are just serving to our concrete group and also to other required clients about that. It's also a specific product. The advantage of we have ability to produce its different fineness range according to requirements, and high durability, chemical resistance, workability, late and long-term strengths. It helps, and its compressive strength development, as you could see in here, that it's just increasing with later age after 28 days. And heat of hydration effect, it's also very effective with that product. Some near projects, as an example, MR Square project in Istanbul, we just gave it's more than 70,000 tons, and also one of the most critical projects, important projects in Turkey of last year is Marmaray project, world's deepest submerged deep project. Again, more than 60,000 tons of GGBFS supplied to that project. Now I want to just talk about a little bit about the carbon vegetation with GGBFS. It's also critical for us. We are decreasing our footprints with specific products without performance losses. And we could produce high quality cements and specific brands with low CO2 effects. The first series, 42.5 types, and the series Star Sem, Cementum, and Power Sem, you could see that up to 20% we could decrease our cement emissions. And the other series, it's extremely chemical resistance series. It's just, and also their reactivity is also very good. Durasem series. With Durasem Plus, it's a 32.5 cement, but it could be used in concrete mixes. We could decrease nearly 58% less carbon dioxide footprint when compared with the SEM 140, ordinary Portland cement, SEM 142.5. Not only the cement side, also specific CO2 emissions. We are just designing our receipts and other things. We are decreasing on the concrete stage. I just give an example of the nearly more than 70% of our products based on C2530 group type of class of concrete. As you could see that it just that's the figures of last year 2020, and we could reduce more than 18% specific CO2 footprint effect on the concrete side per meter cube of concrete, and also nearly 130,000 tons of CO2 emissions decreased only by that R&D and product design approach in concrete operations. It's nearly equals the 5.5 million trees in a year absorption of carbon dioxide. And at the last new potentials and next stage, I want to just give some details about it. We are working on some R&D and product development stage. We are looking for potential synergy of DOH clay, which is our brand name in calcined clay operations. We believe it will be much more critical to reach CO2 emission of cements to less than 200 kg per ton of cement. It's also critical for near future. New ternary cements, it's also we know that EN under than 97.5 just is ready, and we could mix much more slag calcined clay on it. We focused on that license, and we will just serve our clients with that by the help of that new standard, higher flexibility and new products. And also ultra low carbon concretes, not only with binders, also with aggregates. We focused on it. Some demolished one, the aggregate operations. We are planning to also decrease our effects of carbon dioxide effect and also minus effect carbon dioxide aggregates, as we know that capturing CO2 by some aggregate operations. It's also aggregate technology. We are focusing on also those technologies. Thanks for your listening. Thank you about that. I could answer your questions. Robert, can you hear?
Yeah. Thank you very much indeed. So I think that is your QR code for anybody that wants to link in with you.
Yeah, that one is my one, and our company's website in the right bottom part. They can reach our company's website.
Fantastic. So thanks very much indeed, Berkan, for a very, very interesting presentation. Absolutely fascinating presentation, and it's very, very interesting to have the standpoint of a cement producer and a slag cement producer in particular at the Global Slag Conference. Not necessarily something that we have very, very often, so it's really good to have your viewpoint on this. There are a few questions that perhaps I can start with. So the Durasem and Durasem Plus slag-based concrete, slag-based cements, they presumably have a slight disadvantage in that their early strength is relatively low relative to OPC1. Do they have a cost advantage?
Yeah, on the cement side, there are some deficiencies about early strengths, but we could control it and we could do adaptation in the concrete ready mix side, because that products are really high effective control in the ready mix receipts and their workability. They're also very compatible with ready mix admixtures. We could control by using some specific admixture contents to control it, especially on our concrete designs. We could eliminate that deficiency at that stage.
Right, okay, so I was just wondering whether or not you employ perhaps fine grinding or ultra fine grinding to help improve the early strength of the concretes, and what additives would you be using to help the early strength? But my original question was, is there a cost advantage to using Duracem or Duracem Plus compared to using OPC?
Yeah, there are specific admixtures. As I said, it's just water reducers and some just reagents to just improve the workability and strength performance, especially in the early strengths. But it's related according to projects and the requirements of that concrete rheology on that project. On the cost side, to come to your question, yeah, it's just on cement price basis, it's a cost advantage on it, but on the concrete side, the most advantageous part in the concrete side by the use of that product, because ordinary Portland cement in some projects, especially with Duracem projects, it's not possible to use OPC because of that high heat of hydration, because it's just using some just block concretes and some specific projects to resistance to chemical attacks and other thing. Low alkali contents or low C3A couldn't help it. By the help of that Duracem, that effect improved so much. As I explained, we used that product in the Marmaray project and just some bridges and some ports, chlorine and just seawater effects. It really works well, and it's specifically requested product.
Very, very good. Okay, so we have a few other questions that have come in. Amit Mehta asks, what is the source of your slag, and do you import slag at all from Japan?
No, just we are just the originally Turkish that we're using on our group synergy. Because of that, it's an important industrial symbiosis issue for us. We are just getting value of the value of that product and improving, and just not only in the Turkey, we are just both and use that product and also just exporting that product as a GGBFS product according to requirement of our clients. Serving also to all world with that product, and we are also doing additional R&D studies about it to improve that product's potential, because the decreasing CO2 levels with new phase 4, it will be also much more critical, and low amount of fly ash, just decreasing amount of that slags. We know the potential of that product, and we will use it to decrease more CO2 emissions on cement and concrete.
Okay, so forgive me just for 1 second. I'm going to launch a poll right in the middle of our questions, and this is going to be quite interesting. We're going to have to be quite quick about this. So the question is this: is slag one of these? Is it a waste? Is it a byproduct? Is it a co-product? Is it a product? Or it depends, okay? Which one of these is slag? A waste, a byproduct, a co-product, a product, or does it depend? Now, I'm just going to give you another 5 seconds on this. 5, 4, 3.
It's a I can say that a co-product.
Oh, sorry. Okay, so I'm asking all of our audience to vote on this. I'm just going to give them another 5 seconds. 5, 4, 3, 2, 1. I'm closing the poll, and I'm going to share the results with all of you. you say that the majority of you say that it's a byproduct, followed by a co-product, a product, and it depends. And only 7% of you say that it's a waste. So I think that is something that the vast majority of people in the slag industry would largely agree with. They would say it's not a waste. Don't use the W word. It's not a waste. It's only a waste if you throw it away and don't add any value to it and bury it in a hole in the ground. That's not a good thing. We need to put it into the circular economy, add value to it, and reuse it again. Okay, hopefully that was of some interest. John Klein asks a particular question. He says, how many tons of calcined clay are you currently producing? Are you actually, is this a research product, or is it actually a product, a research project, or is it a product that you're producing and selling into the market?
We had commissioned the world's first calcined clay line integrated grinding plant, cement plant in Abidjan in Ivory Coast. It's in August of 2020. We could produce around 30-35 ton per hour calcined clay. We have a capacity like that plant, and it's also we have actually producing. That's not an R&D project. And our second project also will be commissioned at the first half of next year in Cameroon. And we are looking also for opportunities on Europe and also the other regions of the world with potential of that material, because we believe that it's also critical. And we believe we have been doing some R&D analysis to just its adaptation with other supplementary cementitious materials, especially with slag. The calcined clay with slag could be a great potential to produce ultra low carbon cements.
Right. Okay. So Pierre Laveche Dubois asks, what is the average percentage of ground granulated blast furnace slag that you use in your ternary cement blends, LC3 cements?
There are some specific products. Currently, we don't have the license, as I explained, on EN 197.5 just officially declared, and we are planning to get the license. We are waiting the country's adaptation about that. The existing part, we produced some trials with SEM5 type. According to SEM5 type, you know that you can decrease down to 20% of clinker. Left percent, you could use calcined clay and slag on that portion, up to 35%, as far as I remember. And we could use just between 30-35% of calcined clay, and also again 30-35% of GBFS in it. We tried that product. It's also an important product.
Yeah, absolutely. So Taku Nagaura asks, will calcined clay be produced in Turkey? And will there actually be a standard in Turkey that would allow that cement to be used?
We are a little bit unlucky in Turkey about that issue, because we have huge natural pozzolans, some truss and pumice availability in Turkey, and also we have, as I said, it's a huge potential of steel GBFS. With that issues, firstly we focused on that co-products. I said co-product, not just the output of that steel companies. We are planning to adding value for that product. Still some fly ash and GBFS still available in Turkey extensively. We are planning to use firstly that one, because calcined clay also requires some heat energy, electric energy, no emission issue, but rather than doing that, just directly focus on that products. But after the other regions, it could be a potential. Because of that, we focused on specific regions like West Africa, Europe, and also some regions around some India, Bangladesh, or just in China part. People are also just focusing on that product due to availability of that product. But a raw material side, yes, the specific kaolitic and illitic clays are available in Turkey, but due to abundancy, due to availability of all that other cementitious materials, it will not be early possible in Turkey.
Okay. So we have a few more questions. Ashim Kumar Bhattacharya makes mention of ultrafine grinding to improve early strength, but we've looked at that a little bit already. So Kayatai Alp Aslan asks about the possibility of using electric arc furnace slag or steel slag in cement. Do you have any plans in that area?
Yeah, we have R&D studies on it. That material is also critical, on both sides. While producing clinker, those materials can be used due to their high iron content. We are just using it, replacing with iron ore. It's also again synergy, industrial symbiosis. One side of it's producing while clinker, but some arc furnace slag and steel slag is also as a potential on reactivity, not like in GBFS, but there need to be some adaptations on the slag generating slag process, that part. And we are planning to do some just synergy and integration with our iron and steel group about that topic. That there is also a potential, I can say that. Still, it's on R&D stage now, but it will be also can be used as a reactive material.
Wonderful. Berkan, that's all the time we have for questions, unfortunately. You do have a few more questions from Ashim Kumar Bhattacharya, Amit Mehta, Dr. Jagabundu Kole, and Junaid Ahmad, but I will send those people your address for them to get in contact with you directly. Obviously, you've generated a lot of interest and a lot of questions there, so thank you very much indeed for a really fantastic presentation, and hopefully we'll see you sometime at the Real World Global Slag Conference, maybe even in Vienna.
I hope also, Robert. Thank you for that also just invitation, and have a nice seminar to all the participants. Thank you very much again.
Thank you very much indeed. Wonderful. So